Hello, everybody, and welcome to episode 1 of Engineered Success. Today, we're going to be talking about the hardest classes in industrial engineering and electrical engineering. I studied electrical engineering at the University of Kentucky, and Mike studied.
Industrial engineering at Purdue University.
So, that is what we're going to start talking about today. In terms of the most difficult class for industrial engineering, what do you think that is?
It comes down to operations research, I think. I think a lot of people think of industrial engineering as like manufacturing or supply chain, but there's a lot of fields in industrial engineering. There's data science, it's kind of more like applied math in some regards. Then there's obviously the supply chain, manufacturing, things like that. But ultimately, what I think the hardest class in industrial engineering is going to be around operations research. There's a few classes, but a lot of like programming and modeling, math modeling.
What are you programming?
You're programming simulations. So you're receiving different inputs. Sometimes there are static inputs. So you'll get certain variables with certain numbers to them. So x equals 1, y equals 2, z equals 3. But then there's other times where you're going to be getting variable inputs, or we call it like probabilistic inputs. You put it that way.
Got it. So, in terms of electrical engineering, I would say the hardest class is electromagnetics. And to me, that class, what it felt like was everything in the physics 2, electricity and magnetism, the worst parts of it, the hardest parts of it, all in just one class,
As an
amplified.
as an electrical engineer to an industrial engineer, can you explain what electromagnetics actually is?
So that's a good question. I think one thing that I remember, it's been a while since I've taken it, but the specific class, one thing I remember mainly it goes into is like radio frequencies, things like that.
Laplace transforms?
Not that I recall, no.
Oh, that was just an
No.
industrial engineer's
So
guess.
that is the second hardest class, which is signals and systems. And basically interpreting an electrical signal.
I see. Okay. Okay. And then with the hard classes, so you had electromagnetics, systems and signals is another hard class. You kind of stumbled on talking about like the classes specifically, and I don't want to like, that's not like a joke. So
Right.
how many years has it been since you graduated?
So it's yeah, the thing is it's been since I've taken those classes, it's maybe been 4 or 5 years.
You've never looked at the material since then, right?
Right, which is
Okay.
why I'm having. Did I know the material well in my prime? Absolutely. The thing is now 5 years later, 4 years later, you sort of lose your edge.
So then people ask this question and they go, "What's the point of studying engineering?" You learn all of this stuff, and it's not like, and I'm not calling you out for it. Like there's certain stuff in IE where I'm going to be like, I need to like recollect my thoughts on what this stuff actually means. What do you think then, if you can't remember it specifically, like the equations, the definitions, everything like that? What's the value in your point of view for getting an engineering
So
degree?
the value of it, there's two things. Number one is the actual knowledge that you get. So the electromagnetics, if you want to work on, say, maybe satellites or antennas specifically, like stuff like that, that's a really important class. And the actual material that you learn will end up being directly applicable. So that if your goal is to end up working and doing work with satellites, important to know that stuff. And then in signals and systems, an interesting thing where I'll give an example where signals and systems are applied is inside of images on a computer. If you want to take an image on a computer and save it in a way where it maybe takes up less storage on the computer, you're basically, without going into the detail, you're using principles from that class that allow you to then save and store information at a where basically you're using less storage to store that information. So like I said in that example, a photograph. If you take a photograph and it's on the computer and you have a copy of the photograph digital copy on your computer. You there's basically principles of what's going on in the signals and systems class to save that file in a format that requires significantly less storage. So there's practical everyday examples, and so that's great if you're going into a job that requires it. But outside of that, I think it is more than anything just the rigor that is more than anything a signal to employers that you're able to do hard things.
To add a third one there, it's so you mentioned there's practical application if you go into a field that actually uses whatever you learned in the
Yes.
in the class, and of course. But then there's also rigor demonstrating that you're good at solving problems, that you can handle, tough situations. Engineering's not easy, difficult major. But then I think if I were to add just a point number 3 before we wrap up here, would be problem solving and like kind of thinking through going from 0 to 1 in an entire problem set. And one of the things that I noticed during my engineering degree is the right answer is like very rarely given like full credit just for getting the right answer. You got to show all the steps to get there. If there's 10 steps in the problem, it might be an 11-point problem. For 1 point for every of the 10 steps, are you doing it right? And then just attack on another point for getting the right question or the right response or the right number at the end of the question. So there's a very good chance like you can get like a 91% on the problem, do all the 1 through 10 steps correct, but not get the right answer, and you got a 10 out of 11 points on that problem set. And I think that's the third value. There's a ton of values of studying engineering, but what we're talking about here, the third value would be knowing how to approach problems and how to diagnose problems and then go about finding a solution. I think those are, in both of our experiences, getting an engineering degree, very valuable, even if it's not like directly related to what you do in your career after.